Good morning, pirates. This week we are going to start our study of limits of what we call transcendental functions. We have so far covered a lot about limits, but oddly enough, this is only lesson 5. It should give you a good indication of how rigorous the course is next year. We'll do one of these lessons in almost a day starting next year. So right now we're blessed to have some extra time and to take our time in learning limits, which are truly the foundation of calculus. So it's pretty sweet that we have that time. But let's get right into it. So before we can talk about the limits of a transcendental function, I think it's important to know what a transcendental function is. How I describe it as it is a function that transcends algebra. So typically algebra formulas are like your polynomials, your rational functions. Those are your algebraic functions. These functions include exponential functions, trig functions, and any inverse of either an exponential or a trig function. And so when we talk about transcendentals, what we're really talking about is e or an exponential function, ln or a log function, and then our trig, our 6 trig functions that we know pretty well. Okay, so the first thing I wanted to kind of go over is your knowledge of exponential functions and their behavior. So when I look at example A, I see a function that has a growth rate of 1.5, right? And we look at the function, we can tell that it's growing. We can see that, let me highlight this, that we have a positive x here and a positive x here, and it's greater than 1. We're in pretty good shape. And so let's talk about the limit as it behaves. Anytime you see limits to infinity, we are talking about what we call end behavior. So how is the function behaving at the end? And so as we approach negative infinity, we see this transcendental function going to -3. And we can locate that by, of course, that value that is added or subtracted onto our exponential. But because this is a growth function, we expect that as we approach positive infinity, this thing to just keep growing. So we're going to say infinity, therefore dne. And so what is important for you to be able to do is to look at the function and decide whether it's growth or decay. Because once you know that, then that'll give you some indication about its end behavior. So let's take a look at function b. Function b is a decay function. We can tell this is because the b value is between 1 and 0. We can also see that we have a positive x term up here and a positive base, so we're in pretty good shape. Now, after seeing the first example, I hope that we notice the -3, which would mean one of our end behaviors is going to be at -3. And so now we look at the graph, right? And we're lucky today we have the graph. And so as I approach negative infinity, or the end behavior, I'm going to see that we're going to go to positive infinity, right? Because this is decay. And so the negative infinite, or the end behavior to the left, will we keep going, and so therefore dne. And if we look at the limit as x approaches positive infinity, because of that -3, we know that this is going to approach -3. And typically if there's not anything added or subtracted there, then it's going to approach 0. Okay, so now we have 2 more examples, but these examples change things a little bit. If I look at this first function, based on the e alone, this should be a growth function. But because we have that negative out in front, it makes it decay. And so when you are looking at just the functions, try to recognize those things. It's a decay function. We have that +2, so we should know that our end behavior is going to be up 2 somewhere. Now let's look at the end behavior. As x approaches negative infinity, there's that +2, right? And because it went from growth to decay, we know that now, as we approach positive infinity, we're going to get closer and closer to negative infinity. Therefore, D and E. Okay, example D, we look at the number on the inside, and this is B is in between 0 and 1, which would have made it decay, but because we now have this plus sign, it's going to make this function growth. Oh, I just spelled growth wrong. Oh boy. Growth. Okay, we have the plus 2 again, so we recognize that the end behavior will be up 2 from either the left or the right, depending on the graph. And so as we approach negative infinity, we are headed to negative infinity, therefore D and E. But as we approach positive infinity, we have that highest value of 2. And so the next stage of this is to look at these without the graph. And so I'm going to give you the same functions. And what I would like you to do today is I would like you to identify whether it is growth or decay, how many reflections it would have. So a reflection would happen again if the term here is negative or there's a positive or negative out here. And then I want you to go back and examine the end behavior of these 4 graphs. This is your assignment today. My expectation is tomorrow we're going to pick up with examples 2 and 3 right from this assignment. Hopefully you can take some time and really think about these functions. You do not need to graph them because of course they're right here, but what you will be really focusing on is recognizing if it's a growth or decay from the function and the number of reflections that happen. Okay, good luck. Please reach out to me if you have any questions. Like and comment on the video, and please send me a screenshot of this chart completed. Have a great Tuesday.